Hey everyone, welcome back, and today we'll be doing another Leetcode problem. Problem number 867, transpose of a matrix. This is an easy one. Given a 2D integer array matrix, return the transpose of the matrix. Transpose of a matrix is a matrix flipped over its main diagonal, switching the matrix row and column indices. So that's it. We are going to switch the rows and column indices, but it is very easy when you have a square matrix like this, but it becomes tricky when you have a non-square. You can say a matrix that is not in square form. A rectangular, you can say matrix. So here in this case you can see that 2 minus 10 and 18 are going here are column, and here it will be in the resultant form. It will be in the form of a row, and 4 5 6, so do 1 minus 1 11 and 6. So if we have our matrix in an example 2, you can see in this rectangular form, then what we'll be doing is just pairing the first two, then again the second column, and then again the third column, and just making it another matrix. So now we have to just form a matrix in this form that can have a null value or a zero value. So what we will be doing is, for every column we have, so the length of column, so for the length of column we want to have these uh, pairs. So the for the length of rows, you can say, so for the length of rows, because this is 2, and go till the length of a column. So a column here are 3, so obviously we'll be making the length of 3. So that is the stretchy part. Otherwise this is a pretty easy problem. So for starting we'll be having a row and column. So for length of matrix, that will give us column, and for the column we will have length of matrix at 0. Matrix at 0. Okay, so we'll be making our output matrix, where we will have 0 at each position of row. So if row is 2, then obviously we are going to have a list of 2 where every value is 0. So for I in range go till, we have columns. So this will make a 3, you can say, matrices, 3, uh, not 3 matrices, but a pair of 3. Yes, a pair of 3 if we have our row in, um, if the row is 2. So now, so for every c, let's just start with r. So for every row in, we will be going till range of row again. So for column, so for I in range, not I, c in range of columns, and output at c and R will be the matrix value at R and C, because these indices are swapped. And now what we can do is just return the output. So that's it. Let's see if this works. This works, and let's see how things are going. So our limit is going to be, R is 2 and C is going to be 3, and here R from the starting is 0. So for 0, and so for R is 0 and column is 0, the value is not swapped basically, because this is the value at the same locations. For the first value and the last values are, you can say, are still going to the first and last. And now we'll be going again in the column, so this will be converted into 1 0. At 1 0 we are going to have 2, so this 2 will be having at 1 0. So 1 0 is this location in the output one, and now again this is going to be incremented at 2. So 3 is now going to be at 0 2. So 0 2 is going to be this location, and now R is going to be incremented and C is going to be 0. So this R is going to be at 1 0 1. So 0 is going to be this parameter, this index, and now here it is going to be the one location, and same will go with 2. 5 will be in the 1 0. So 1 0 is going to be 2 1 2 1. So 2 1 is going to be this location, and now in the matrix 3 1 it will be 6, which will be at the very last. So that's it.